In this video, we're going to talk about factoring trinomials of the form ax squared plus bx plus c, where a does not equal 1, right? That means that we're going to have a number other than 1 as our leading coefficient. And so there's basically two methods or two ways that we can do this. The first method, I'm just going to call it the trial and error method. And this is where we just pretty much try things. Let's look at this example so that we can go through the trial and error method. We have 8x squared plus 2x minus 15, and we want to factor that completely. All right, these are going to work similar to when a does equal 1, and that means, what I mean by that is that we're always going to factor these into two binomials. All right, and what we're going to do here is we're going to still use the fact that, okay, from our full method, we know that, hey, whatever I put in these first spots here have to multiply to give us that 8x squared, right? And so if you really think about 8x squared, I'm going to come off to the side down here, right? I want to think of two things that I can multiply to give me 8x squared, right? I can multiply 8x times 1x, or I can do 4x times 2x. And so what's that telling me here is that in these first spots here, I have two options. I can write it as either 8x here and just a 1x here, or I can write it as a 4x times a 2x. Notice that when I use my full method, right, in either of those cases, I'm going to get back to having this 8x squared, which I see right here. All right. We also know from our full method that the thing that we put in these last spots here, here, and here comes from things that multiply to give us this negative 15. And so if you think of negative 15, there's a lot of options for this, right? We can do 15 times a negative 1, a negative 1 times 15. We can do a 5 times a negative 3, or a negative 5 times a positive 3. And so what we should worry about is putting these numbers here, these pairs of numbers, all right, we got 4 pairs here, into these second slots in our sets of parentheses here. And the thing that makes this hard is that we're just doing this by trial and error, right? We can no longer rely on these things totaling up to 2, all right? Like we did when there was a 1 in front of our x squared, right? Because, well, if you think about it, you could use 5 and negative 3. Let's say we used 5 and negative 3. They do add up to a 2, but where am I going to put it? Am I going to put the plus 5 here and the minus 3 here, right? If I do that and I try to fold it back out, I'm going to have 8x squared. When I fold it out here, so that's going to be an 8x squared, I'm checking myself, minus 24x. Here, my inside, I'll get a plus of 5x, and then I'll do my last, which would be a negative 15. Right? Notice that these two middle terms, when I combine them, they don't equal this negative 2 right here. All right? And so let's say I try it with this example here, right? With the 4x's and 2x's. Let's say I do plus 5 here and minus 3 here. All right? When I fold it out, 4x times 2x is 8x squared. 4x times negative 3 is negative 12x. Here, I have plus a 10x. And I have a minus 15, right? Of course, I almost have it because when I multiply that negative 12x by the 10x, I get a negative 2, whereas I need a positive 2 here. So neither of these work, all right? So I want you to understand that, hey, even though these pairs of numbers, they do add up to the positive 2 that I need, kind of when we were looking at the stuff from the last section, it does not work with these numbers here. However, if you look here, I'm pretty close to getting a positive 2 here. Well, I got a negative 2, but I ended up getting a positive. I need a positive 2, but I'm ended up getting a negative 2 here. So what I'm going to do is I'm going to sort of switch these signs to see what happens, right? I'm going to do a 4x minus 5. So I'm going to come down here and I'm going to erase that. So let's think about this. So I'm just going to come down here, 4x minus 5 times 2x plus 3. Let's see if that will work, right? I'm going to check myself by filling it out. I'm not going to draw those arrows since I'm running out of space. But 4x times x is 8x squared. 4x times 3x is a 12x. Negative 5 times 2x is a minus 10x. And a negative 5 times 3 is minus 15, right? Notice that when I do combine these two terms, I do get the positive 2. Therefore, I have my answer here, okay? This is the trial and error method. It can take a really long time depending on what we have in these first and second spots here, all right? And so what I'm going to do is I'm going to go over a different method that you can use to help you factor polynomials of this form here, all right? We're going to ignore this polynomial here, and I'll just go through the steps, and then we'll see how we can do this method. Some people call this the rainbow method. But it basically involves the following. The first thing we want to do is factor out any GCF, right? And the reason why I want to do that is because sometimes it looks like we're going to have to do this method, but the leading coefficient can actually be factored out. It's kind of like this 4 here. Sometimes this 4 can be divisible in each of these numbers, and if we factor the 4 out, we're actually going to be in the case of all the problems that we had in the last section. So I always try to factor out my GCF if I can. Then what I'm going to do is I'm going to multiply A and C. And I always want you to remember that when we're dealing with quadratics, it's in the form ax squared plus bx plus c. These types of polynomial. I'm saying multiply A and C. Whatever my leading coefficient is, I'm going to multiply it by my constant term. All right? And some people write it like that, and that's why we call it the rainbow method. Multiply those two numbers. I'm going to find all the factors of A and C, but I'm going to choose the specific ones that add up to B, all right? And again, B is this middle term right here. So I want to multiply these two things here, find two factors, two numbers that go evenly into it, that add up to this coefficient on the X term that's in the middle, all right? The purpose for me doing that is so that I can rewrite the BX term using those two factors, all right? And then I'm going to factor by grouping. All right, let's see that. The goal of the rainbow method is to end up with 4 terms instead of 3 terms. Look at this example here. We have 4x squared minus 25x plus 36. Right now it has 3 terms. What I'm going to end up doing is I'm going to multiply. All right, notice I don't have a GCF here, but I'm going to multiply this 4 by that 36. 4, multiply the 4 and the 36. And when I multiply 4 and 36, I'm going to get 144. Okay? So this is that second step. Now I want to find two numbers that multiply to give me that 144, which I just found, but add up to negative 25. Add up to negative 25. And so notice here, they have to multiply to give me 144, but add up to a negative 25. That means both of my numbers are going to be negative. All right, and you can go through the 1 and 144, right? How many times does 2 go into 144? 2 and 72, right? And you can continue to go down through the factors of 144, but what you're going to find is that when you get to 16 and 9, they work. 16 times 9 is 144, and if I make both of them negative, when I combine them or add them together, I get that negative 25. All right, and so these are my two numbers that I'm going to be using in order to help me go to my next step. And the next step says to rewrite your BX term, this is that negative 25x, using those two factors. So what I'm going to do is I'm going to leave my 4x squared the same, but now instead of using negative 25x, I'm going to use a negative 16x minus a 9x. Plus 36. Notice I've rewritten the middle term. It is negative 16x minus 9x, which is the same thing as negative 25x if I were to combine like terms. But now you can see that I have 4 terms in this polynomial. And so what I'm going to do here is I'm going to start factoring by grouping. Group the first two together, group the second two together. Once I group them, I can factor by grouping out of the first two terms. let's factor out a 4x. We're going to be left with an x minus 4. Out of the second two terms, let's factor out a negative 9. We're going to be left with an x minus 4. Both of these terms have an x minus 4 in them. And so what I'm going to do is I'm going to factor out that x minus 4. And out of that first term, I'm going to be left with a 4x. Out of that second term, I'm going to be left with a minus 9. All right, and now I have it factored as two binomials, so I know that I am done. Let's look at another example. Here I have 10x squared plus 2x plus 12. I want to factor that by using the same method here. All right, in this example, notice that all of these coefficients are even. That means I can factor out a 2. All right, so that's what I'm going to do first. I'm going to factor out a 2. So I can write that as 2 times 5x squared plus 13x plus 6. Notice here inside of that parentheses, I still have a number other than 1 in front of my x squared. So I'm still going to use my rainbow method. All right, to do that, I'm going to multiply the 5 and the 6, and I'm going to get 30. All right, and I want to find two numbers that multiply to give me 30, but add up to this 13 here. All right, 13 is my coefficient on the x. And if I think I can multiply a 10 and 3, that'll give me 30, and they also add up to 13. And so what I'm going to do is I'm going to rewrite that 13x as 10x plus 3x. All right, and now I've gone from having a polynomial with 3 terms to having a polynomial with 4 terms. And now I can factor by grouping. Notice here that I keep my coefficient or my great GCF that I factored out. You never want to get rid of that, all right? But I'm going to continue, right? I'm factoring by grouping, so I'm going to group the first 2 and the second 2 terms together. I'm going to get a 2. Out of the first 2 terms, I can factor out a 5x. I'm going to be left with an x plus 2. And out of the second 2 terms, I'm going to factor out a 3, and I'm also going to be left with an x plus 2. Now, even though this looks real weird with all these parentheses, right? These parentheses here, this one and this one represents those. And now I have these parentheses from this x plus 2s when I factored out each GCF here. All right? But I'm going to continue. Don't let the parentheses confuse you. I still have that 2 on the outside. But since this is the same as that, with factoring by grouping, I can factor that out. So I can factor out this x plus 2. And out of this first term, I'm going to be left with a 5x. And out of the second term, I'm going to be left with the plus 3. All right, and I factor that completely. Notice I still have this 2 on the outside from the very beginning, so never get rid of that. And everything on the inside just is the same as before. Going through that process to turn it to factoring by grouping. Let's look at 2 more examples. All right, my next example is 2x squared plus x minus 28. All right. Notice here, I don't have a GCF, right? That's a 2x squared plus x minus 28. So since I don't have a GCF, I'm going to go ahead and I am going to multiply that 2 by the negative 28. 2 times negative 28 is negative 56. And so my goal is to find 2 numbers that multiply to give me negative 56, but add up to a positive 1. Right? Notice it has to multiply to give me a negative 56. That means one of them is going to be positive and one of them is going to be negative. And I also know that there's a 1 in front of this x here. So the numbers that I choose, when I add them together, it has to be a positive 1. And so if you think about all the numbers that you can multiply, give you negative 56, a positive 8, and a negative 7 will work. And so I'm going to rewrite this as 2x squared plus 8x minus 7x minus 28. All right. And again, I rewrote this 1x as an 8x minus 7x, which is exactly the same. Now I have 4 terms, so I'm going to factor by grouping. First 2 terms, I can factor out a 2x. I'm going to be left with an x plus 4. Out of the second 2 terms, I can factor out a negative 7, and I can be left with an x plus 4. Now that I have both of these x plus 4s here, I can factor that out, x plus 4. And I'm going to multiply that by the 2x minus 7 that's left after I factor out the x plus 4. Also remember in all these examples, you can multiply it all back out in order to check yourself, just as we've done previously. All right, we're going to look at one more example, and this last example is a little complicated because the numbers in this, or the coefficients, are pretty large. All right, I have a 56x squared plus 121x plus 63. All right, and if I look at this, it may seem to have a GCF, right? At least if you look at 56 and 63, you think 7. 7 goes evenly into both of them. 121 is a bigger number, so I'm going to get my calculator. I'm going to see how many times 7 goes into 121, and hopefully it's evenly, but it's not, right? If you put in your calculator, you're going to get a decimal. That means 7 doesn't go evenly into 121. With that being said, I don't think there's any other numbers that can be a GCF. So we don't have a GCF in this example. So what I'm going to do here is I'm going to get right into things. I'm going to multiply this 56 by this 63, right? 56 times 63 is 3,528, all right? And so my goal here is to find two numbers that multiply to give me 3,528 that add up to 121, all right? So these numbers are going to be pretty big, all right? If you feel that this is too big, right, you can start dividing, going through 1 and 3528, right? 3528 divided by 2 is 1764, so I have 2 and 1764, right? Of course, adding these numbers is not going to give me to 121. I may have the longest list ever here. And so if you feel like you want to try the trial and error method and that'll work better for you, by all means do so. I'm going to try the trial and error method because I don't want to go through this entire list, right? I got to go and divide 3 by it, 4 by it, 5 by it, 6 by it, right? And see if these things go evenly. I can already tell that 5 won't go evenly, but some of these other numbers might, and I might have a very, very long list that may take a very, very long time. And so what I'm going to do is I'm just going to look, right? I have a 56x squared here, and I have a 63 here. So I'm going to do trial and error. One way to get 56x squared is to do an 8x and a 7x. And one way to do 63 is to multiply 9 and 7. So I'm going to do plus 9 and plus 7. Okay? All right, now I'm going to multiply this out. I'm going to check myself using multiplication just to see if I did that right. Because if I did that right, that's perfect. I don't have to worry about it. I'm done, right? So I'm going to FOIL it out. 8x times 7x is 56x squared. 8x times 7 is 56. 9 times 7x is 63x. And 9 times 7 is 63. All right? And so if I add the 56 and the 63, I'm actually going to get 119x. All right? So this does not work for me. And so I'm going to try it a different way, right? Let's say I do 8x plus 7 and 9x. Sorry, that should be a 7x there. 7x plus 9, right? So all I'm doing is switching the order of this 9 and this 7 here, right? Now I'm going to check and see if that is correct. And if it is, awesome, I'm done with that problem, right? So you'll use the FOIL method. 8x times 7x is 56x squared. 8x times 9 is 72x. 7 times 7x is 49x. And 7 times 9 is 63. All right, if I add those middle terms, the 72 plus the 49, I actually do get 121x. So this is, in fact, my solution. Again, I decided to go back to trial and error since this number here, when I multiply my A and my C, was too big, and that is perfectly fine for you to do. All right, this concludes our video on this section.